Good morning, class. I am going to create a video to help you out with sections 4.1, 4.2, and 4.3. I'm going to use one problem that's in section 4.3. It's problem number 6. This one problem does everything that's in 4.1, 4.2, and 4.3. So that's why I'm going to cover this. It'll help you out. Be sure to watch the process. In these sections, we're dealing with linear regression. And if you remember in algebra, you had an equation y equals mx plus b, where m was the slope and b is the y-intercept. Well, that's the concept that you're using in this section. So in this problem, there is a box that you can check, and that contains your data. You can open that up and open it up in StatCrunch. I've already done that over here. And I'm going to close out this box. So notice we opened up the data, and what we want to do, the first problem says draw a scatter diagram. Now if you remember in algebra, your horizontal axis is your x-axis and your vertical axis is your y-axis. Well, in linear regression, the x is called the explanatory variable and the y is called the response variable. In this particular problem, in part A, it tells you to treat company A as the explanatory variable. So what we're going to do is we'll let x be company 1 and y be company 2. And so we're going to create a scatter diagram. Now you can see there's 3 to choose from. If you come over to Stat, and everything you do in 4, 1, 2, and 3 comes from this. You go down to Regression, come over to Simple Linear, and then notice my explanatory variable is going to be company 1, my response variable is going to be company 2, and then you just click Compute, and you will get a table that has all the information that you need. Now what's going to happen, you'll have to spread this out. If I can get a hold of this. We're going to pull this over. Notice there is an arrow at the bottom of this screen. If you click that, it's going to show you the graph. Notice right here how there are some points right here that make a curve. They're very close to this line. Okay, they're not exact, but they're close. And we're going to talk about that in just a minute. But if I come to choose, notice this first one, it has we have company 1, and up here we have company 2, and there's our curve. Notice this one does the other direction. This one is going to the negative side on the number line. Also, this one had company 2 as our x, so we can take that one out automatically. So this is the one we're going to choose. Okay, the next thing, I'm going to come back and I'm going to click the arrow, and it's going to ask you to calculate the correlation coefficient. That is our R. That measures the strength of the linear relationship between company 1 and company 2. Now, your R value is always between, let me write this, it's always between -1 and +1. And your R is always somewhere in the middle. What happens is, the closer it is to these values, the closer the points are to a straight line. Now if R is 0, that means there's no linear correlation. If R is close to a -1, it means there is a correlation and it has a negative slope. If R is a +1, that means there is a linear correlation and it has a, whoops, this is a negative slope, that's a positive slope. Okay, so back to this. Notice how this is leaning to the right, so it's a positive slope. Now, in our chart, we have everything that we need to answer this question. Notice it has rate of return. We're looking at this part right here. Let's see, right there. There's your equation. You're going to need that later. The rate of, this is the y equals mx plus b. Notice this is your sample size. We'll need that in a few minutes. That means there were 12 pair of points. There is your correlation coefficient, your R. We're going to need R squared in a few minutes. We'll use that. If they ask you to find the sum of the squares residual, that is right here, SS and error. That's the sum of the squares residual. I remember there's some questions about that, so if you need that later. But anyway, this one's asking you to find your correlation coefficient. So we will type this in. Notice my correlation coefficient is 0.949, and that's what I'm typing in this box. Now, here's what we're going to use this for. This is very important. If my absolute value of my R is greater than the critical value, that means there is a linear relationship. Now, the problem is, where do we find our critical values? Well, on this particular one, it does not have a box to check to find your table. So if you go to your course information and you go to your formula sheet, I'm going to pull this up, all the value, here's my, if you scroll down on your formula sheet, here's your critical value table. Remember, I have 12 pair of points. This is my critical value right here, the 0.576. So right now I have R is 0.949, and I have my critical value is 0.576. So here's what I want to use. I want to take these and compare them. Notice my R is greater, so that means there is a significant linear relationship. So right now, they ask us a question. Let me see if we can pull this back up. They ask you, based on the scatter diagram and the correlation coefficient, is there a linear relation between company 1 and company 2? If you go back and look at the graph of this, you can see these points are close, but the main thing is look at the R value. This R value, the correlation coefficient, is close to a positive 1. It's 0.94, or close to 0.95, we'll say. So it's close, so yes, there is a linear correlation. Okay, the next thing it asks you to do is to find the least squares regression line, treating company 1 as explanatory. And it says choose the correct answer. That's right here. Notice that's where this would be our Y, so it's like Y equals. Be careful because these are turned around compared to what's in MyLabs Plus. This is my M, that's my X, that's my B. So when I go to select the right one, it's going to be the one that's Y hat equals 1.5204X plus 0.0364. Okay, so we have our equation written down. We're going to use that in a minute. Now, question 2. Predict the rate of return for company 2 if company 1 is 10%. Now, this is something you need to know, so this is part E. You've got to know this. If the absolute value of R is greater than the critical value, then we use the equation to make a prediction. All we do is take our value and we're going to plug it in for X. But if the absolute value of R is less than the critical value, we can't use the equation. It's not linear, so we have to use the mean of Y, the Y bar. Remember, if you have to find the mean of Y, you go to Stat and Summary Stat and find the mean. But on this one, we know R is greater, so you're going to fill in. Now, it said use for 10%. We got to change 10% to a decimal, 0.01. We're going to take that 10% and plug into our equation. Our original equation is this. We're going to plug in the 0.01 and work this. So notice our prediction is this. So what we're saying, if company 1 has a 10% rate of return, we can expect that company 2 is going to have an 18.84%. Okay, so that's our prediction. But in this, they just want the decimal. Okay, but part F is when you compare something. Now notice my rate of return in company 2 would be 0.1884. The percent of that would be 18.84. You move your decimal 2 places. Part F says if the actual rate of the company was 13.6, it says when the rate of company 1 was 10, was the performance of company 2 above or below average? Okay, go back to this. You are comparing 13.6 to the 18.84 we predicted. 13.6 is your observed value. 18.84 is our predicted value. If you subtract those two, what happens is that's called your residual. Okay? if you look at those, notice the actual value, 13.6, is less than this, so that means it's below average. So if you're comparing these two, notice let me see if I can find it, 13.6 is below this value of it. You look at it as a percent, so it's below. Okay, next thing. Interpret the slope. This problem has a lot in it. It covers everything that we've done. So here we go. Let me review something. Slope. Slope is y2 minus y1, x2 minus x1. So slope, the numerator is the y's, the denominator is the x. So if I go back to my equation that I wrote down right here, this is my slope, 1.520. So what I'm going to do is write it over 1. And remember the bottom parts are x, this is our y. Well, we've wrote this up here at the top. My x is company 1, my y is company 2. So here's my interpretation. Remember we're talking about rates of return, so if the rate of return of company 1 increases by 1%, notice then we can expect company 2 to increase by 1.520%. So notice that is D. For each percentage point increase in the rate of company 1, the rate of company 2 will increase by 1.52%. Okay, let me turn the page here. I'm running out of room. So if you notice, make sure you write things down because it's going to ask you to show work on these problems, and what I'm doing is writing everything down as I go along. This is what you need to do. Okay, interpret the y-intercept. Remember, the y-intercept is the n number in your equation. It's this value right here. This is your y-intercept. When I go to write the y-intercept, I write 0, comma, the number. Now, this is my x, this is my y. Remember, that's company 1, that's company 2. So they say, interpret this. So what that's telling me, if there's no change in company 1, we can still expect company 2 to increase by 0.0364%. So notice the interpretation. The y-intercept indicates the rate of company 2 will be 0.0364 when there's no change in company 1. Okay, that's your rate of return. And finally, here's the last part. You have a section, let me think, I'm trying to think of which section. Anyway, the coefficient determination, I think that's the one we're in right now, the 4.3. Coefficient of determination is r squared. It's also called the proportion of variability. So you're going to see in this problem it says what's the proportion of variability in the rate of company 2 is explained by the variability in the rate of company 1. Go back to this. All this is talking about is this r squared right here. They took this number and they square it and they come up with this. This is called your proportion of variability or your coefficient of determination. So they asked me to tell the percent. Notice it has a percent sign. So all I have to do is move my decimal 2 places, move this over 2 places, and notice there's a 90% proportion of variability. Let me explain what that means. The proportion of variability or your coefficient of determination means the same thing. You are looking at your second value. Now, if you go back, remember the y, let me find it. Hold on just a second before I tell you. Yeah, your response variable. I was trying to think. Y is your response variable. What happens is this tells you what percent of y can be explained by x. So here, I wrote it out. This means that 90% of company 2's rate of return can be explained by company 1's rate of return. Also, you'll see a lot of times they'll say this means that 90% of company 2's rate of return can be explained by the equation. They'll say that. So anyway, this is a problem that covers all of linear regression. So I hope it helps. Thanks.